All right, I want to go ahead and talk about the last page of the review. Let's take a look at it. It says use the parallelogram JKLM to find each measure. 18 says measure angle JML, so I need to go ahead and find that. So where is JML? So here's JML. Okay, so since this is a parallelogram, note that opposite angles are going to be congruent, right? So this angle here, the opposite to that angle is this angle over here. So if this is 109, of course this is going to be 109. So what does that mean? That means that JML is 109 degrees. Okay, so now I want to go ahead and figure out what JK is. So here's JK. What is the opposite side of JK? Well, that's going to be ML. And that's one of the properties of parallelograms because opposite sides are congruent. So if this is 6, then that is 6 as well. Okay. KLM. All right, so KLM. Okay. So since these are consecutive angles of a parallelogram, then we can go ahead and say that, well, 180, because this is a line, minus 109, that's going to give me, what is that going to give me? 71. So KLM is 71 degrees. Okay? Quadrilateral DEFG is a rectangle, so we can assume this figure is a rectangle. If DF is 2x, or 2 times the quantity x minus, or 2 times the quantity x plus 5 minus 7, 2 times x plus 5 minus 7, and EG is 3 times the quantity x minus 2, we're going to go ahead and find the value of EG. So since this is a rectangle, the diagonals are congruent. Okay? So if the diagonals are congruent, then we can set them equal to each other. So we do 2 times the quantity x plus 5 minus 7, which is equal to 3 times the quantity x minus 2. And then I'm going to go ahead and use the distributive property, which is 2x plus 10 minus 7, which is equal to 3x minus 6. And then I'm going to go ahead and combine the like terms. 10 minus 7, that's going to be 2x plus 3, which is equal to 3x minus 6. And then after that, if I subtract both sides by 2x and then add both sides by 6, I'm going to be left with x is equal to 9. Okay? But I'm not looking for x. The problem doesn't state that I should be finding x. It asks me to find what EG is. Well, here's EG. It's 3 times the quantity x minus 2. So if I know what x is, I'm just going to plug it in. EG, which is equal to 3 times 9 minus 2. 3 times 9 minus 2, that's going to be, well, 9 minus 2 is 7. 7 times 3, that's 21. My answer is 21. The measure EG is 21. Okay. 22. It says measure angle EDF, which is 5x minus 3, and DFG, that's 3x plus 7, okay? So what do I have to do? Well, I know that, so here's 5x minus 3, and here's 3x plus 7, right? And a rectangle is a special type of parallelogram. So that means we have parallel lines here, and it's going to be cut by a transversal. So then if this is my transversal and if this is my transversal and 5x minus 2 is right here, and it's, on the opposite side of where 3x plus 7 is, that's what we call alternate interior angles. So I do 5x minus 3, which is equal to 3x plus 7. So now I'm going to subtract both sides by, 3x, which I have 2x. And then I add both sides by 3, I get 10. So I get x is equal to 5, okay? But I'm not looking for x. I'm looking for the measure angle EDF. So EDF, again, is right here. So I will do 5. So measure angle EDF is equal to 5 times 5 minus 3, which, 5 times 5 is 25. And I subtract that by 3, that's going to be 22. Okay, so this is 22 in terms of its measure. 23, if measure angle FDG is 62, so FDG is 62. I want to find what DMG is. So let's see, DMG. Okay, so do you see this triangle over here? So one thing that you have to know, now I need to go ahead and erase everything so it makes a lot of sense. So I'm erasing everything here. FDG again is 62, and I'm trying to find what DMG is. So DMG, I'm trying to figure out what this angle here is, right? Now, we can't say that this is 90 degrees. We can't say that this is 90 degrees. That's not right, because 90 has to be a right angle. This here is not 90 degrees. But there's something that you have to note about a rectangle. The diagonals are congruent, and they're going to bisect each other. It's going to create a midpoint, yes? Okay, so actually, let's go ahead and use a different color here, not using my laser point. So here, the diagonals are congruent. So it creates this midpoint here. So that means that if I'm looking at this segment, alone, individually, well, if this is my midpoint, then it's going to be, half. It's going to split the segment into two congruent parts. It's going to be even. So this side is congruent to this side, right? And then, since, again, this diagonal is congruent to this diagonal, then it's going to follow the same suit. Right? So if I take a look at this small segment here, it's going to be congruent to this segment as well. So that and that, they're going to be the same length, as well as this segment over here. So then what do I have? If I take a look at this triangle here, if I take a look at that triangle here, well, what do I have? Well, this is an isosceles triangle, right? This is an isosceles triangle, which means that since I have two sides that are congruent, then the angles opposite to those congruent sides are also congruent. So this is 62, so this has to be 62 as well, okay? And my goal here is to figure out what this angle here is. So this is a triangle. The sum interior angles of a triangle is 180, right? So I do 180 minus 62 minus 62. That's going to be 56. So the measure angle DMG is 56 degrees. And that's my answer. Okay? Now here it says determine whether each quadrilateral is a parallelogram. Okay, so a quadrilateral again is a four-sided figure, 360 degrees. Now I need to determine if it has the characteristics of a parallelogram. Well, number 24, opposite angles are congruent. Notice I have one arc here and one arc here. These angles are opposite to each other, and then I have two arcs here and two arcs here, and these angles are opposite to each other as well. So opposite angles are congruent. So parallelogram, this is a parallelogram because opposite angles are congruent. Number 25, let's take a look at it. Is this quadrilateral? It's a four-sided figure. Is it a parallelogram? Well, remember, with a parallelogram, 1, opposite angles got to be congruent. 2, opposite sides must be parallel. And 3, opposite sides got to be congruent. So if I take a look at this, don't be fooled. There's only one tick mark here and 2 tick marks there. These sides are opposite to each other, but they are not the same length, just due to the fact that they have different tick marks. So no, not a parallelogram, because opposite sides are not congruent. Opposite sides not congruent, okay? All right, so it looks like we are here. This is the last problem, so let's go ahead and draw this parallelogram, or plot the points to make it look like a parallelogram. It has the vertices 3, 4, so 3, 4, 3, 4 is right here. So that's K. And then, what else? L is 5, 1. Then we have -1 comma -3. And then -3 comma 0. So then I'm going to go ahead and connect these points. And then obviously it looks like a rectangle to you, right? Yeah, I know it looks like a rectangle, but I got to show my work to get all the points I need. So, I'm sorry that you have to do it, but you have to. So we need to check the diagonals of this figure. So number 1, check the diagonals. If the diagonals are congruent, it could be a rectangle or a square. If the diagonals are not congruent, then it could be a rhombus. So number 1, check the diagonals. And to check the diagonals, you need to use the distance formula. So you need to do d equals the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. And we're going to go ahead and check the diagonals, or the diagonal k. I'm sorry, I didn't label these. So that's -1 comma -3. That's m. And the other one should be n. Okay. So we need to check the diagonals of km. How long is km? Or no, yeah, that's km. Then if I plug everything in, if I use the points, you're going to use these points here, km, plug it into the distance formula, you're going to get the square root of 65. Okay, so now, once you're done with that, you're going to go ahead and plug in the values of n and l. So d of nl. And, if I, use the points and I plug into the distance formula for NL, you're going to get square root of 65. Okay? So, since the diagonals are congruent, this could be a rectangle. So, could be a rectangle or a square. Number 2, I need to check the slopes of the diagonals. Now, you can use the slope formula, or if you want, you can go ahead and rise over run. Okay? So, let's figure out the slope of NL. So, I'm going up 1, then right 1, 2, 3, 4, 5, 6, 7, 8. So, I'm going to go 1/8 for that slope, and then I can go ahead and check the slope of km, which is, so here's k and here's m. I like to start from left to right, so I'll use this point here. So I'll go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So I have the slope of km, the diagonals of that, 7/4. So the diagonals are congruent, but the slopes are not perpendicular. So what does this mean? It's a rectangle. If the slopes are perpendicular, it's a square, but we have 1/8 and 7/4, so this is a rectangle. Okay? So that is your answer.